Hello, everyone. Have you ever wondered how you can ensure that your instructional design is set up to ensure learners' success? Well, this video is going to explore several instructional design theories and principles to make sure you are not cognitively overwhelming your learners. The first theory that we want to discuss is cognitive load theory. In order to understand cognitive load theory, we must understand our cognitive architecture. Cognitive architecture is made up of three elements. They are your working memory, which is severely limited, long-term memory, which is limitless, and schemas. So the goal is, as learners take in information into their working memory, which again is severely limited, it can only hold approximately 2 to 4 elements of new information at a time, we want the learner to be able to integrate the information from their working memory into schemas. Schemas are organized based off of previous knowledge that the learner may have about the topic. Once the information gets integrated into schemas, that's when it gets shifted over into long-term memory, which is usually when the learning becomes generated or sticks, making it click, as we say. So, when we are talking about cognitive load theory, we need to think about 3 types of cognitive load that the learner will encounter. The first type of cognitive load is extraneous load. Extraneous load is any additional information, text, audio, visuals that is not directly relevant to the learning topic. So these extra pieces of information often distract the learner and act as noise that can harm the learning process and cognitively overwhelm the learner if the extraneous load is too high. The next thing that we will talk about is intrinsic load. This is the number of elements or complexity of the learning material that the learner is dealing with. So for example, if we're talking about a large algebraic equation, the intrinsic load is increased by the number of elements or variables that may be presented into the problem. And finally, germane load is the process or integration that happens when the learner integrates the information into schemas and clicks it over into the long-term memory that hopefully makes the information stick. The big idea of cognitive load theory is to reduce the amount of extraneous load, manage the number of elements or intrinsic load, and facilitate that process of making it stick, known as the germane load. Now let's look at the cognitive theory of multimedia learning. In the cognitive theory of multimedia learning, there are 3 assumptions. The first assumption is that we process information through 2 channels, our auditory channel as well as our visual channel. The second assumption is that, similar to cognitive load theory, that working memory is extremely limited. And the third assumption deals with active process. The active process is where the learner selects the information that is significant and organizes it into a schema that then gets integrated into long-term memory. Similar to cognitive load theory, we have processing load that we need to be aware of. Essential processing is the material that is directly relevant to the learning topic or content. The extraneous processing, similar to extraneous load, is the noise or any extra elements that do not facilitate the learning process. And then finally, Generative processing, similar to the domain load, is the process of organizing information into schemas and making the information click. Similar to cognitive load theory, we want to reduce the extraneous processing, facilitate or manage, we want to manage the essential processing, and we want to facilitate or encourage the generative processing. Now let's talk about 4 instructional design principles that can help ensure that your instructional design approach is solid and does not overwhelm the learner. So the first principle that we want to talk about is redundancy. When you are using multimedia, you need to make sure that the information you're providing is not redundant. So for example, if you are narrating a presentation, it is not helpful to have the exact same script written out on the slides. In other words, we want to make sure that we are providing text and images that complement what we are saying to the learner. Because with redundancy, what happens is if the learner has to spend time trying to process the exact same information visually and through their auditory processing, it can be cognitively overwhelming. So an example of this is flashcards. Many of us learned with flashcards on how to read, where we have the text, an image, and someone speaking the word to us. Research has actually found that because when we eliminate the redundant information of the image and just have the text, as well as the teacher or parent reading the word to us or narrating the word, that eliminates redundancy and actually facilitates a higher level of reading. So, in other words, research has shown us that we want to make sure we are finding information that complements and is not redundant. The next instructional design principle I want to discuss is signaling. Signaling is extremely critical because it forces the learner to focus in on the relevant topic that we want them to gain knowledge or understanding of. Ways we can use signaling are, for example, in this slide here, are to highlight or color code a visual so the learner is focusing in on the area that we're talking about. So for example, on this slide here, we can see we are emphasizing neurotransmitters traveling over the synaptic cleft. So we really want the learner to focus in on that synaptic cleft. Signaling helps with cognitive load because, again, it shows the learner what they need to focus in on, and they can minimize the extraneous content that they could be exposed to without signaling. Coherence principle, similar to redundancy and signaling, removes any extra fluff that is not relevant to the learning content. Many times new instructional designers make the mistake of putting too much extra media into their presentation to try to fluff it up or make it exciting. However, this extra content, such as background music, visuals that don't make any sense, or animations, are actually distracting and can harm the process of learning. So coherence is the process of eliminating those extra noise. Finally, refutation text focuses in on changing the current conceptions that the learner has about a piece of information. There are 4 elements that have to happen in order for refutation text to work and for learners to change their conceptions. They are, the learner has to be dissatisfied with the conception. The new conception must be simple and understandable. It must be reasonable and relevant to the learner. So with refutation, text, we have three parts. We have a misconception, a cue, and a refutation with a scientific explanation. Now I'm going to go over how I use the 4 principles of instructional design that I just discussed in a professional development presentation. Many people think appreciative advising can only be used in advising scenarios. However, research has found appreciative advising techniques are beneficial in administrative roles as well, such as working with a subject matter expert and instructional design team. I'm going to focus on the disarm phase, which in the disarm phase, I get to know the content expert. So in other words, I help define the roles of the instructional design team and how we can help create and facilitate the process of online course development. I like to hear from the subject matter expert on what went well in their previous courses that they have taught. What do they help to emulate into their online course development? And then we explore what are some challenges do they have about online learning? For example, are they not sure how to get students to collaborate with one another? Thank you all for watching this video on how to create engaging instructional design materials. I hope you stay tuned and good luck creating.